Hello everyone, today we'll be presenting the findings of our saturation flow rate study. So for the introduction, this study was conducted at the intersection of South Marietta Parkway Southeast and Cobb Parkway Southeast, focusing on the rightmost eastbound through lane. The data was recorded on a Tuesday afternoon where the traffic volume was fairly high. The main objective for this experiment is to find the saturation flow rate, the startup delay, and the maximum green time for the eastbound through lane, and to determine if the intersection is satisfying the flow rate requirements adequately. So here is the overhead view of the lane that we chose. It's the eastbound through lane. And so here is a point of view of the intersection of our chosen lane. With the stoplight highlighted, which is what we looked at to determine the cycles. So for our effort statement, for our contributions to this report, Dallin did the data collection and prepared the results. Brad did the discussion, Tori prepared the conclusion, and I did the introduction and objectives. So I'll pass it over to Dallin to talk about the results.
Thank you, Davis. So this table represents the variables that are used to determine saturation flow and capacity. A few important takeaways from these results are that 6 of the 15 cycles required clearance to pass the intersection, and that the majority green light time on South Marietta Parkway eastbound varies widely from about 20 to 50 seconds. The maximum green time observed is 52 seconds, occurring during cycle 10. It is important to note that the majority of green light intervals were 23 seconds long. To take into account the saturation flow and capacity, cycle 10 was analyzed. For cycle 10, the average headway is 1.89 seconds. The saturation flow is 1,902 vehicles per hour per lane, and the startup delay is 1.3 seconds. The saturation flow for cycle 10 is 19% lower than the average saturation flow, which is 2,336 vehicles per hour per lane. Moving on, as shown above, there are 3 charts. Table 1A demonstrates the values for cycle 10 and just reiterates the saturation flow. Table 2 demonstrates the capacity versus saturation flow for cycle 10. And in order to solve capacity, the ratio between effective green time over cycle length were multiplied by the saturation flow. When analyzing the lane at a macro level, the average saturation and capacity are both higher. The average saturation is 2,336 vehicles per hour per lane, and the value for capacity raises to 763.8 vehicles per hour per lane. The flow ratio of capacity over saturation flow was determined as 33%. And I'd like to pass it to Brad to discuss these results further.
All right, thank you. So the calculated average saturation flow, as Dallin said, was 1,902 vehicles per hour per lane, which corresponds well to the average of 1,900 vehicle per hour per lane according to a University of Idaho paper, which was referenced later in this presentation. The saturation headway at 1.89 seconds also falls close to the average of 1.9 seconds listed in that paper. Our maximum green time observed was 52 seconds for cycle 10, which is much more than the average green time of 27 seconds. This is likely due to there being nobody in the opposing left lane that's going westbound to southbound, so the green time for the left turn was likely added to the green time of our cycle 10 data. Also during the max green time, there was the least amount of traffic through the lane we were measuring. This may be a random coincidence, but more investigation will be needed to determine the validity of this claim. The average capacity of 763 vehicles per hour per lane seems reasonable, especially when considering the amount of lanes in this direction. The saturation flow of 33% also seems reasonable for this amount of phases in the cycle, and the relatively similar amount of traffic that flows in the intersecting road, which is Cobb Parkway, going north to south. More studies may need to be done to determine if this intersection and specifically our observed lane needs any adjustments, but overall the performance seems adequate.
In conclusion, this study at the intersection aimed to evaluate various traffic parameters, including saturation flow rate, startup delay, and maximum green time for the rightmost eastbound through lane. Through data collection and analysis, it was determined that the average saturation and capacity for the lane were notably higher. The flow ratio of capacity over saturation flow was calculated at 33%, indicating a reasonable distribution of traffic flow. Furthermore, the observed maximum green time of 52 seconds for cycle 10 was notably higher than the average green time, likely influenced by the absence of traffic in the opposing left lane. The measured startup delay of 1.3 seconds for cycle 10 with an average delay of 3.2 seconds suggests reasonable traffic flow conditions. However, further investigation is warranted to validate these claims regarding traffic distribution during maximum green times, as this is only one lane with 15 cycles. Lastly, this lab is in contradiction to previous labs of the opinion of this lab not being an efficient light, but further study needs to be conducted. And these are our references. Thank you for watching today. Have a good day. Okay.